So for our Unit 8 problem, our original equation is this. And the first thing you're going to do is you have to take the derivative of each term, which will give you 8y minus 8 equals 18x plus 3. And any term that has a y, you have to add dy dx. So I just went ahead and did that. And then what you're going to do is you're going to factor out the dy dx, which will leave you with 8y minus 8, and then you'll divide by 8y minus 8 to get dy dx by itself. So our final answer will be 18x plus 3 over 8y minus 8. For our Unit 9 problem, this is our original equation, and the first thing you need to do is discover what the domain is, but since it's just a normal function with no fractions or anything, it's automatically all real numbers. And the next thing you're going to do is you're going to take the derivative of the original function, which will give you 6x squared plus 6x minus 12. And you can factor the 6 out of that to simplify it to x squared plus x minus 2. And then what we're trying to find is the value of x, so you'll factor that out one more time. And then you'll solve for our x's, so we'll get x equals 1 and x equals negative 2. So then what we're going to do is make a number line with negative 2 and 1, and you're going to pick a number to the left of negative 2, so I chose negative 3, and you're going to plug it into your simplified equation, and it will give you a positive number, so you'll write a plus right there. And then here I just used 0 as my number, which would give us a negative, and then here you can use 2, which will give you another positive. So what this means is that the function is increasing from negative infinity to negative 2 because it's positive, and it's also increasing from 1 to infinity because it's positive right there. But then it's decreasing from negative 2 to 1 because it is a negative sign right there. And then to find your maximum, which you can see will be at negative 2 because it goes positive to negative. To find that, you will plug in negative 2 to your original function, which will give you 24. So our max is at an x value of negative 2 and a y value of 24. And then to find the minimum, which will be at 1 because it goes negative to positive, you will plug in 1 to the original function, which will give you negative 3. So the minimum is at an x value of 1 and a y value of negative 3. For the Unit 10 problem, we needed to create a graph that follows these rules. So let's walk through it. The first thing that we have to have is that it's continuous for all values of x, meaning we're not going to have any holes or asymptotes or anything that will make it discontinuous. And then our next thing is we need to plot our values here. So what these mean is that at the x value of negative 2, our y is going to be 3, which we have. And then at the x value of 1, we need a negative 4, which we have. And then at the x value of 4, our y needs to be 5, which we have. And then all of those points that we just put dots at, we also see they are all equal to 0 for f prime, which means that the direction is changing at those points. And then down here, what f prime of x is greater than 0 for negative infinity to negative 2 and 1 to 4. What that means is that the slope is increasing at those points. So you can see that here and here we have our slope increasing where it needs to be. And then for f prime of x is less than 0 for negative 2 to 1, and then 4 to infinity. So what that means is our slope needs to be decreasing between those x values, which you can see we have. And then finally, our f double prime of x is greater than 0 for 0 to 3. What that is saying is that our slope or our graph is concave up, which we have, and then for it being less than 0, it needs to be concave down, which you can see we have perfectly. So that is how you graph when you are just given information like this. So our Unit 11 problem says, given the cost function, c of x equals 2,600 plus 500x plus 0.9x squared, and the demand or the price function P equals 1,500, find the production level that will maximize the profit. So first, we know that our profit equation is revenue minus cost, and our revenue is P times X, and our P is 1,500, so 1,500X. And so then what we're going to do is we're going to put in our revenue, so 1,500X, and then subtract our cost function, which was given up here, from it. And then you can simplify that down to negative 2,600 plus 1,000x minus 0.9x squared. And then what you're going to do is you're going to take the derivative of that, which will give you 1,000 minus 1.8x. And then to find the max profit, we have to solve for x. So we're going to set that equal to 0, and then subtract 1,000 from both sides. So we'll get negative 1.8x equals negative 1,000, and then you'll divide by negative 1.8 on both sides. So x equals 556 units. So the production level to get the max profit will happen at 556 units. Our Unit 12 problem is a problem that we're going to solve the integral using u substitution. So here is our original equation, and then what we're going to do is we're going to set u equal to what's inside the parentheses. So 3 plus 4x squared. Then we're going to get the derivative of that. So du is equal to 8x plus dx. And we want to get dx alone. So we'll divide by 8x, which will give us 1 over 8x du equals dx. And then we'll go back over here and we will sub in our u and our du value. So, and I just put it over 1, our x u to the second, because we're subbing in u for what was there. I just put it over 1 because we have a fraction over here. And then we put du. And then you can simplify that down to x times u squared over 8x du, and we can cross out the x's, which will leave us with u squared over 8 du. And then to get it back to its original form, we have to add to the exponent, so plus 1, and then multiply the denominator by the new exponent. So we'll multiply 8 times 3, which will give us u cubed over 24, and then you just add plus c as your constant. And then the final step is to plug in your u value back in to get your final equation. So you'll just plug u, what you have up here for u, back in to give us 3 plus 4x squared cubed over 24 plus c. Okay, and for our Unit 13 problem, we are given our bounds of 4 and 0 and 4x dx. So we're going to integrate that, which will give us 4x squared over 2, because you just add to the exponent plus 1 and put it over the new exponent. And that can simplify down to 2x squared. And then 2x squared with the bounds of 4 and 0. To get our final answer, you will plug in our top number first. So you'll do 2 times 4 squared, and then you will subtract the same function, but you'll plug in the bottom number, so 0 for the x. So negative 2 times 0 squared, and the final answer will be 32. And then to solve using geometry, you will make a graph, and we know that our x bounds are 0 and 4, so we will set those up, and then we know it's going by 4 because of up here. So you'll plot your dots increasing by 4, and then to get the area of it, the area of a triangle, because it will create a triangle, is 1/2 base times height. And you can see our base is 4 and our height is 16. So you'll do 1/2 times 4 times 16, which will give you 32. So you can see the answers match. And this is, if you're asked to solve a problem one way, solving it the other way can be a good way to check your answer.